Hello, my name is Samjit K. Sahal, and today we're going to talk about electromagnetic spectrum. And so, what is electromagnetic spectrum? It is a variation of wavelengths being formed when beams of light go through an angle or a prism. And it's a spectrum that is rainbow colored, and any form of light that is visible to the naked eye, and it could also help us see what is not visible to the naked eye. So this is actually a triangle, and if a light goes through this certain angle, we're able to see different types of colors, which is why it's called the rainbow colored spectrum, because those colors help us identify the type of radiation or wavelength that we're able to, let's say, determine when we witness EM spectrum in general. So three things we have to know about EM spectrum are: first, infrared radiation; second, atmospheric windows; and third, the Doppler effect. So, firstly, infrared radiation. It is an energy that's invisible to the eye but detectable as heat, and it also helps astronomers in viewing cooler objects or regions of space, such as exoplanets and clouds of cosmic dust. So, with the first definition, what I could tell you is that this is what we use when there's something that is not visible by the naked eye. We use infrared radiation, like say a certain thermometer, to actually be able to see or to actually detect the heat and be able to figure out something that could help us know more about this certain element. So, like in this picture, as you can see, in the first picture, you can see very faint colors, right? And it's a Milky Way, let's say. And it's a very, very faint colored picture. And which is visible to the naked eye. If you see it from a telescope, this is what it will look like. However, if we use infrared instead, as you can see in the second picture of the infrared one, we can see varieties of colors. We can see certain elements being popped up on the picture too that are not seen in the first picture, which means infrared radiation helps us to see these elements without being able with the use of heat and with the use of certain tools that could be used when it comes to detecting this type of heat, so that we're able to gain more knowledge about the certain element at the end of the day. Second are atmospheric windows. So these are light and radio waves that can help in viewing space from ground-based telescope. And the level of radiation or energy transparency varies accordingly with the wavelength the light goes through, like radio waves, microwaves, infrared radiation, visible light, UV rays, X-rays, and gamma rays. So the difference between infrared and atmospheric windows is that in infrared radiation, we're able to see what type of radiation we're receiving. However, in atmospheric windows, we're able to see the intensity of radiation we're receiving, what type of wavelength it is, what type of how strong is this radiation that we're receiving from the outer space to the Earth's atmosphere. That's the difference between atmospheric windows and infrared radiation. And astronomers use these windows to determine the type of radiation they're receiving from space that hits the Earth's atmosphere. So, like I've explained a while ago, it helps us determine how strong or how weak the certain radiation is and how we're able to cope up with it, or how it actually affects the Earth's atmosphere at the end of the day. Third thing is the Doppler effect. That's the apparent change in the frequency of a wave caused by the relative motion between the source of the wave and the observer. And astronomers use the Doppler shift to calculate exactly how fast an object is moving toward or away from the observers. So as you can see in the picture, it says that, a blue shift means towards the viewer. If it's a blue shift, then it means it's actually very nearby the viewer or the observer. If it's neutral, then it's actually in a very average level. However, if it's red shift, then it's a very farther from the viewer. Like for me, for example, my computer is in front of me. What I can tell right now is that I'm in the blue shift zone because I could see it very nearby. However, if I have to view the sun or any other planet on the outer space, that will be red shift because I won't be able to see it that far, and it's very far from me. So it is a distance between the observer and the certain element that we're looking through. And now, for the last thing, we have to talk about the James Webb Space Telescope, which is it is used to detect the faintest traces of infrared light, the wavelength of light emitted by everything that produces heat. And this telescope's primary power is to detect faint galaxies as further as possible. So as you can see in the pictures, that these are some of the images that it was able to capture, and this is something that we can actually see with the basic telescope or with any other telescopes that are out there in outer space. However, James Webb Space Telescope was able to see all of this, and this is actually the James Webb Space Telescope, and these are the images that it was able to capture. And this is used to actually view or to take pictures of something that's very far that cannot be seen by our naked eye or by even the Hubble telescope or any other telescope aside from this one. So it helps us to figure out more about the universe at the end of the day. So overall, what I think about electromagnetic spectrum, it's a very important concept in us for to actually know the basics of space or how it affects the Earth's atmosphere at the end of the day. And with all of this, with the help of EMX spectrum, we're able to see, the the differences or the basic foundation as to what makes it as to what makes us gain more knowledge about certain energies, about certain lights, about certain wavelengths or radiations that affect not only the Earth's atmosphere but even the people who are living in it. And through certain, let's say, telescopes or other knowledge or other experiments, we're able to get to know more about the universe that helps us in the long run, figuring out what are the things that we're supposed to do when it comes to preserving human Earth, or when it comes to, making sure that we know everything in order to deal with something that might happen in the future. So these are the references, and I hope you had a great time listening to this video. Thank you.